Okay, let us solve some problem on pure substance. Find the saturation temperature, the changes in specific volume and entropy during evaporation, and the latent heat of vaporization of steam at 1 megapascal. Okay, what we need to find out here is saturation temperature, change in specific volume and entropy during evaporation, and the latent heat of vaporization of steam at 1 megapascal. Now, at 1 megapascal, from steam table, we can find that set at 1 megapascal pressure, saturation temperature is 179.91 degrees Celsius. Okay, from the steam table, you can get this value. Saturation temperature of water at 1 megapascal pressure is 179.9 degrees Celsius. You can get it from steam table. Similarly, Vf, which means that enthalpy of water, I mean latent sensible heat of water at this pressure, you will get this from the steam table itself. And this enthalpy of evaporation or latent heat of evaporation, we can get this value from the steam table itself. Now, what he has asked is the change in specific volume. The change in specific volume is Vfg, which is Vg minus Vf, which will be 0.193 meter cube per kg. Similarly, we need to find out the change in the entropy also. So by finding out the entropy of water as well as entropy of steam. So difference between these two will be entropy of vaporization, and that will be 4.4 kilojoule per kg Kelvin. Difference in the entropy by bringing water at 100 degrees Celsius to complete dry saturated steam at 100 degrees Celsius. So entropy change will be 4.4 kilojoule per kg. And similarly, change in enthalpy value. Okay, three parameters we need to find out here. At 1 megapascal pressure, change in volume, I mean change in specific volume is this much, and change in entropy is this much, and change in enthalpy is this much. So these values we will get it from the steam. Okay, next problem. Saturated steam has an entropy of 6.76 kilojoule per kg Kelvin. What are its pressure, temperature, specific volume, and enthalpy? Okay, from all the values what he has asked can be calculated from the steam table itself. We have to use steam table in order to solve the problems. Okay, what he has asked is, he has given a saturated steam as an entropy value of 6.76 kilojoule per kg Kelvin. Then what are its pressure, temperature, and specific volume? From the steam table, when entropy of steam is 6.76 kg, then at this entropy value, pressure is 0.06 megapascal. Temperature means saturation temperature is 158.85 degrees Celsius. Similarly, specific volume at this pressure or at this entropy value is 0.315 meter cube per kg. Similarly, enthalpy at this entropy is 2756.8 kilojoule per kg. All this value can be found by using the steam table. Now next problem. Find the enthalpy and entropy of steam when the pressure is 2 megapascal and the specific volume is 0.09 meter cube per kg. So let us have a solution here. So to solve this problem, again we need to have steam table. From the steam table, when pressure is 2 megapascal and the specific volume is 0.001177 meter cube per kg, which means that specific volume of liquidities, Vf means, and Vg means specific volume of dry saturated steam, and this much. Since the given volume lies between this Vf and Vg, you can observe from the steam table. Okay, the given volume, specific volume is 0.09, and from the steam table we came to know that Vf, specific heat of liquid, I mean sensible heat of liquid, specific volume of liquid or water is 0.0017 meter cube per kg, and specific volume of dry saturated steam is 0.099. But the given volume, specific volume, is lies between liquid volume and gas volume. Since the given volume is lies between Vf and Vg, the substance will be a mixture of liquid and vapor. It is a wet steam it is. Okay. Vf means it is liquid. Vg means completely dry saturated steam. But the value, if the value lies between Vf and Vg, it is wet steam. And the state will be within the vapor dome. When the two-phase region, the composition of the mixture or its quality has to be evaluated like this. Okay. Already we have seen set of formulas need to be used when we have wet steam. In case of wet steam, specific volume of wet steam V is equal to, at a given temperature and pressure, is equal to Vf plus X into Vfg. X is dryness fraction of a wet steam. So V is 0.09 what he has given, and Vf already we came to know from the steam table. X we need to find out, and Vfg, Vg minus Vf is this much, and X equal to dryness fraction is 90.4%. And at 2 megapascal, HF and HFG value we can calculate from the steam table. Similarly, SF and SFG value calculate from the steam table, and enthalpy at this pressure is HF plus X into HFC. Enthalpy of wet steam at 2 megapascal pressure is 2618.79 kilojoule per kg. Similarly, entropy S is equal to SF plus XFG, X into SFG. So it is 5.95. We have already seen a set of formulas. Please go through those once again. When we have wet steam, we need to consider its dryness fraction. So if the completely dry saturated steam means, no need to consider this dryness fraction. Now let us have next problem. Here, find the enthalpy, entropy and volume of steam at 1.4 megapascal and 380 degrees Celsius. Okay, solution. At pressure 1.4 megapascal from the steam table, saturation temperature is 195 degrees Celsius. Therefore, the state of steam must be in superheated region. Okay. In table, from the steam table, for properties of superheated steam, we can get at 1.4 megapascal and 350 degrees Celsius. We need to find out whatever the property that he has asked. Okay. So one thing he has mentioned, you can observe here, at 1.4 megapascal and 380 degrees Celsius, he has asked us to calculate enthalpy, entropy and volume. So before calculating, first and foremost thing what we need to do is, we need to first identify whether the given steam is wet steam or dry steam or superheated steam. Okay, so how to know that whether the steam is dry, wet or superheated steam? Okay, that's what he has mentioned here. You can observe at pressure 1.4 megapascal from the steam table, saturation temperature is 195 degrees Celsius. Okay, that is what the saturation temperature, but the temperature of the given steam is at 380 degrees Celsius. Whatever the temperature more than the saturation temperature is nothing but it is a superheated temperature. So saturation at 195 degrees Celsius only, the steam will become completely dry. If you still increase the temperature of a steam, then the steam becomes superheated. So that is why steam is at 380 degrees Celsius temperature, which is more than the saturation temperature at 1.4 megapascal. So that is why the given steam is superheated steam. So for superheated steam, we need to find out enthalpy, entropy and volume at 1.4 megapascal. Okay, from steam table at 1.4 megapascal and 350 degrees Celsius, we have these values. And at 1.4 megapascal and 400 degrees Celsius, we have these values. But we don't have actually 380 degrees Celsius. We have for 350 and we have for 400. So when you want to have 380 degrees Celsius, which is intermediate temperature, so by interpolating between 350 and 400, we can calculate specific volume at 380 and enthalpy at 380 and entropy at 380.